All right, we all know AI has gotten crazy good at understanding words. But our world isn't just made of text, right? It's full of images, videos, sounds. So how do we teach an AI to actually see? Well, that's exactly what we're going to dive into, the incredible magic behind what are called multimodal models. And this really is the central question, isn't it? Language models are geniuses when it comes to text, but that's just one piece of a much, much bigger puzzle. So how in the world do you bridge that gap between the world of words and the, visual world we all live in? That's the core challenge we're going to unpack right now. Okay, so first up, beyond just words. To really get this, we have to understand why it's so important for AI to break out of that text-only bubble in the first place. I mean, if these models are ever going to be truly helpful, they need to see the world a bit more like we do. Just think about it for a second. An AI that only gets text is kind of like trying to understand a blockbuster movie with your eyes closed. You get the dialogue, sure, but you miss, well, everything else. To be genuinely useful, AI has got to process all that rich sensory stuff that makes up our world.
And that, right there, brings us to the key concept for today, multimodality. It sounds super technical, but it's actually pretty simple. It's just the ability for an AI model to process and understand information from different types of data, or modalities, like text and images, all at the same time.
This is a great way to picture it. You've got this one, single, powerful model, and you can throw all sorts of things at it, text, computer code, and image, and it just gets it. It can process all these different inputs and then produce different kinds of outputs. It's like a true digital polyglot, fluent in all these different data languages.
So the big question is, how did they actually do it? How did they pull this off? Let's get into the really clever breakthrough that finally gave these language models a sense of sight. And here it is. This is the core idea, and honestly, it is brilliant. The big trick was to treat an image like a sentence made of image words. See, researchers had this aha moment. They realized, hey, what if we could make an image look like a sentence to the AI? If they could do that, they could use the exact same powerful architecture, the transformer, that had already totally mastered language. So how do you turn a picture into a sentence? Simple. Step 1, you chop it up. An AI, specifically a vision transformer, or VIT for short, literally takes an image and just slices it into a grid of smaller pieces, or patches. You can think of each one of these little patches as a single image word. Okay, and what happens next is pretty cool. Those little patches are flattened out and lined up in a sequence, just like words in a sentence. Then they're fed into the model. And at this point, the AI honestly doesn't know or even care that it's looking at an image. To the model, it's just a sequence of tokens to analyze, exactly like text. All right, so now we have an AI that can read an image. That's a huge step, but it's not enough. It's one thing to read the image, but the AI also needs to understand that a picture of a cat and the words "a cute cat" are actually talking about the very same thing. We need to create a shared language.
And that's the next big hurdle, right? Now that the AI can read both images and text, how does it learn that they actually mean the same thing? How do you get it to connect the dots between a bunch of pixels and a string of letters?
Well, the goal is to basically build a universal translator. The whole idea is to train a model that can take both an image of a cat and a description of that cat and turn them both into the same kind of numerical representation. We call this an embedding, and that embedding is just a list of numbers that captures the meaning of the input. And this is what that creates, this amazing shared map of meaning. Think of it like a giant library where things are organized by what they mean, not by what they are. In this space, an image of a cat is a super close neighbor to the words, "my cat is cute." But it's way, way on the other side of the library from a picture of a car. It's all about conceptual closeness.
Okay, this all sounds pretty cool in theory, but how does it work in the real world? Let's look at a famous model that absolutely nails this. This is where we talk about a model called CLIP.
So, CLIP. It stands for Contrastive Language Image Pre-training. Yeah, I know, it's a mouthful. But the way it actually learns to create that shared map of meaning, it's surprisingly intuitive.
It really just boils down to a simple 4-step loop. First, it collects a ton of data. Then it creates those embeddings we talked about. After that, it compares them to see what matches up. And finally, it updates itself and does it all over again. Let's walk through it step by step. Okay, steps 1 and 2. CLIP basically gets fed a massive data set of millions and millions of image caption pairs scraped from the internet. Then it uses 2 different encoders, one just for images, one just for text,
to turn every single image and every single caption into its own separate numerical embedding. All right, step 3. This is where it gets fun. It basically plays a giant matching game. Imagine it has a batch of, say, 100 images and 100 captions. The model then calculates the similarity between every possible image and text pair. It's trying to figure out, okay, which of these are the real matches. And this brings us to step 4, where the actual learning happens. The model gets rewarded for the correct matches. It then adjusts its internal wiring to literally pull the embeddings for the correct pairs closer together on that map of meaning. At the same time, it pushes all the incorrect pairs further apart. And it does this millions and millions of times, getting smarter and more accurate with every single pass. So, after all that incredibly clever training, what's the payoff? What can we actually do with this tech? Now we get to the really exciting part, what this all unlocks in the real world.
You know, having this shared understanding of text and images is a total game changer. It unlocks amazing things. For search, you can now find a photo just by describing it. No tags needed. For classification, it can categorize an image without ever having seen a labeled example before. It's perfect for clustering, grouping similar images and text together automatically. And of course, the big one, generation. This is the core technology that lets us create entirely new images just from a simple text prompt.
So really, the next time you use an AI to generate some wild image or even just search your own photo library by typing beach at sunset, you'll know exactly what's happening under the hood. It's this incredible shared map of meaning that's making the connection between our words and our visual world. And that really leaves us with one final fascinating question. Now that AI can connect to what it sees with what it reads, what's next? What happens when we add hearing, or the ability to understand motion in video? What new, absolutely incredible things will it be able to understand then?